Hi, this is Bill Bond, and today I'm going to talk about how to use Hazus for flood. So I'm going to go ahead and open Hazus. I'm going to assume that you've already installed it correctly. I have another video where I talk about installation, but what I'm going to do is actually go ahead and create a new study region. So today I'm going to talk about how to use Hazus specifically for flood. So what I'm going to do is create first a study region that's riverine flooding only, so it'll be an inland study region, and then I'm going to talk about how to create a coastal study region. So I'll talk about different ways we can do the analysis, and you can follow along with me if you want to. But what I'm going to do right now is I'm going to create a new study region. So I'm going to hit create a new region and click OK. Then I'm going to give that new region, I'm going to click on next. Then I'm going to call the region. I'm actually going to do the Lynchburg, Virginia area, so I'll call it Lynchburg Flood. If I want to put a description here, I can do that. So what I'm going to do is just do a basic analysis. The basic analysis in Hazus is usually called a level 1 analysis. So what I'll do is just go ahead and call it level 1 basic analysis, level 1, and I'll click on next. I'm going to do a flood only region, so I'll click on flood and then click on next. And it is actually a city, so in Virginia they have the cities and counties in the same database. So I'm just going to click on county here, and I'm going to click on next. Most people will probably do a county analysis. For the flood model, you definitely do not want to do a state analysis, and really I would not do anything more than like 2 counties at the max. Otherwise you'll have issues with your analysis. It'll just take too long, or it will actually crash maybe on day 2 of the analysis. So I am going to select Virginia as my state. So I made sure I had my Virginia state data already on my computer. And I'm going to click on next, and I'm going to select Lynchburg here from the list and click on next again and then finish. And you'll see it'll take a few minutes to create the region. It has to go to that state data and pull everything from Lynchburg into a new study region. So the video I'll create on installation, I'll also discuss where these files are located, where you can get to them. But for right now, just know that they're on my computer already downloaded. I went to the Map Service Center, I downloaded the data, and then I extracted it onto my hard drive. So we'll just take a few minutes here to wrap this up. And you'll see it basically takes a couple of minutes to create a study region. It also depends on how the size of your region. So if you are doing a multi-county region, it'll take longer. If you're doing a small jurisdiction, it'll take less time. And what it's doing is actually creating a folder, a study region folder on my hard drive with the same name as the study region name. So Lynchburg Flood will be created here, and all the data will be put into that folder. Okay, so it's finished aggregation, and I'm going to go ahead and click OK. And I still need to go to open a region and click on OK. Okay, a lot of people forget to do that. I'm going to click on next here, and then I'm going to select next here, and then finish. Okay, so I selected the region I just created, and now I'm going to open it. So you'll see it opens up in ArcGIS. In the ArcGIS software, you'll see the 4 additional menu options that are available to me now that I have Hazus open. Okay, so inventory, hazard, analysis, and results are added to your typical ArcGIS menu. I'm not going to talk too much about inventory right now. I'm going to have a separate video on updating your inventory, but just be aware that there is data provided by Hazus for your inventory in case you don't have that information, and that data is kind of broken up into two different types. You have data that's aggregated at the census block level in the flood model, and then you have site-specific data. So essential facilities are site-specific data. So if I were to select essential facilities here, click on that, you'll see a menu comes up that shows my medical care facilities, my schools, my emergency centers. These include my EOCs, my fire stations, and my police stations. Okay, so if I wanted to map the police stations, I could click on map here and close, and you'll see my police stations that have been mapped. The essential facility data is actually coming from the Highfield data set, so it's a national data set. So if you do have better local data, you may want to replace it with that better local data. So one thing I do recommend doing is just kind of mapping this information. So going into your essential facilities, mapping your hospitals, mapping your schools. There's going to be a lot of schools usually. And just kind of going through and verifying these locations. One way to do that is I can actually zoom in here. Okay, so it looks like a hospital here. What I'm going to do is just remove some of these layers, and I'm going to add a base map. Okay, so I add some imagery here, and that'll come in behind my hospital points. Okay, so you can kind of see there I've got my hospital. Okay, and my hospital locations there represented by a point. Okay, so although the hospitals are a polygon footprint area, Hazus represents the polygon as a point. So this can be a little troublesome in the flood model because if the floodplain just catches the corner of the facility and my point is over here in the center of the facility, the model will actually show no loss, okay, to that hospital, even though there is a floodplain in it. Okay, so I'll talk about how to deal with that a little bit later, but just be aware of that. That is one limitation with modeling structures as points instead of a building footprint. Okay, I'm going to zoom back out here. So you can see those points were pretty close to on top of the hospitals. These are actually fairly good now with using the Highfield data. But you can basically go through, and what I'll do in the flood model is after I create my floodplain, and you'll see I've got a pretty major river along here. After I create my floodplain, what I'll do is I'll zoom in to any facilities that are near the floodplain, and I may have to actually move those points into the floodplain if the building footprint is in the floodplain. Okay, so that's something that you may have to do. But at this point, it's not really worth it because I don't know where my floodplain is. So it's something I have to figure out first before I start moving all these points around. Okay, so that's some of the point data. We also have high potential loss facilities in the software. Okay, so these can include dams and levees, nuclear power plants, military installations. For the flood model, the flood analysis does not support these data types, so it will not give me a loss for a dam or a levee or military installation, none of these. The flood model doesn't support these, so if I do have these facilities in my area, what I will typically do is I will add them as a user-defined facility. Okay, so a UDF, a user-defined facility, is basically everything else that I want to model as a point. Okay, so if there's something that I really want to see, my community has defined something as an essential facility or critical facility, maybe a utility, maybe a business there on the waterfront that employs a lot of the city. What I can do is actually add those structures as user-defined facilities into this table, and those will be analyzed, and I'll get losses from the flood. Other communities have actually used this to model every single structure in their community. So that's another way that you could do it as well. And I'll actually go through an exercise where I do this, not right now, but in another video. The other type of data in the software is aggregate data, like I mentioned. So if I go to general building stock and I look at square footage, and I look at the table here of square footage, okay, you'll see that I have all these different occupancies that have been classified, and these are all in square footage and thousands of square feet. So this is actually 59,000 square feet, 16,000 square feet. Okay, so just keep that in mind when you start looking at the square footage. You might think it's a little low. Unfortunately, there isn't anything up here in the menu that tells you that it's in thousands of square feet, but just keep that in mind. This is not 3 square feet, this is 3,000 square feet. And this is divided by my census blocks. Okay, and if you want to know what these codes mean, what is Res 3E or what is Com 1, you'll see you have Res is residential, Com is commercial. If I scroll down here, IND is industrial. We also have AGR is agricultural, Gov is government, REL is religious and nonprofit, EDU is educational. So if you want to know what these codes actually mean, what you can do is go to inventory and view classifications, general building stock, and this little menu will define it for you. So Res 1 is a single family dwelling. Okay, Com 1 is retail trade. Okay, so this will help define that. So as you start going through and getting losses, you'll get losses to your Com, maybe Com 1, you'll know that that is your retail trade. So it's important to know when you're trying to express these losses to an audience, to the public, they may not know what these Hazus abbreviations are, so you'll need to make sure you understand what it's showing you here. So if I go back to my my general building stock, I have square footage. I can also show buildings as building counts, so the numbers of buildings, and then also the values, so the actual exposure for the building. So if I click on exposure here, you'll see I've got my menu. I've got general occupancy type, so this is like residential. So it's taking all those Res 1, Res 2, etc., and combining them into one residential column. Okay, so if I want to look at all the residential exposure I have, I can select the column and I can map it. And I'll hit close here. You can see all that data is aggregated at census block level. So if I zoom in here for my census blocks, I can start to see where my residential exposure is. You'll also see that there are some gaps in these blocks. Okay, so these census blocks are called disymmetric census blocks or asymmetric census blocks, and what they've done is they have clipped out the unpopulated areas of your census block. We talked about how Hazus models the points earlier. If the points fall in the floodplain, Hazus assigns a damage to it. However, for the census blocks, what Hazus does is what's called an area weighted analysis. So if the floodplain cuts through part of your census block, okay, it looks at that percentage of the census block and the depths within those census blocks, and it comes up with a loss that's applied to the inventory in that census block. So it actually assumes that the inventory in your census block is evenly distributed across the census block. So what that means is if your floodplain crosses that census block and all your buildings are outside that block, or outside the floodplain rather, Hazus is going to assign damage to this block that may not be good, okay, because there may not be any structures there, so there may be no damage. Maybe your community has built all the structures outside the floodplain. Okay, so keep that in mind when you are doing this analysis at census block level. It's the losses at that individual block are not very accurate. You'll have more accurate numbers if you roll all the values up into the countywide value, because some blocks will overestimate, some will underestimate. So keep that in mind when you start reporting the results. And that's another reason that some communities have actually gone to modeling everything at the site level, to give them a better sense of which specific buildings are actually being damaged. Okay. And also when they clip these blocks, they used land use codes that they felt would not have a structure in them. So things like forest land was removed, when in reality there might actually be structures in that forest land. So one thing I do also recommend is, if you do use this disometric analysis, just kind of go in here. What you could do, again, you can use that base map. You can basically, what I'm going to do is just go to the properties of this exposure layer, and I'm going to make it transparent so I can kind of see through it here. This helps me verify where the structures are located. So I'll hit my display transparent. I'll change that to like 50% and click OK. Okay, and then I've got my rolled imagery here that I'll bring up. Okay, so you can start to see in this example they have clipped out, an appropriate section, okay, of the area. There may be other areas here though. Let me zoom in. So there are other areas. It looks like half a home here has been kind of clipped out. They've added these two areas which may have a structure in them. If I zoom in, maybe not. So again, they did this analysis at the country level. So they didn't do this kind of verification with the base maps when they were doing the processing. So just keep that in mind when you start to use this sort of analysis. What you may want to do is just do a quick look to make sure that you're not leaving out major structures. In some situations, maybe you have a new subdivision that goes in, and it used to be all forest land and it's been cleared and there's now a bunch of structures there. So areas like that you may want to make sure are included in the analysis. The other part is the floodplain. So making sure that when you do map the floodplain, that all the structures within that floodplain are accounted for in your census inventory. Okay, so that's something you can do as well. Alright, so I'm going to go ahead and turn off my base map here. And I'm going to zoom out. Okay, so those are kind of the two major types of inventory in the software. You have the building stock that's aggregated at the census block level, and you have the site-specific data. You also have some transportation systems within the model. So I'll click on that. So in the flood model, the only transportation that could get modeled are the bridges. So the highway bridges, the railway, and light rail bridges. Okay. If you are going to model these bridges, Hazus only supports a probabilistic return period analysis. So you'd have to do something like modeling the 100-year flood or the 500-year flood in order to get damage for the bridges. Okay. So that's a little bit different than the other inventory, which requires a flood depth at the location. Okay, so it's different than the other inventory, so it's not quite as good of analysis as the other data sets. We also have utilities here as well, so these will be shown as points. So look at my wastewater, my water. I can map this so you can kind of see. Look at the treatment plant here. Okay, which is along the river. Okay, we also have the ability to model oil facilities, natural gas, electric power, and communications. Now, if I go to if I look at my analysis and my damage functions, this is how Hazus takes my depth of water and applies a damage to it. If I look at my utility systems here, you'll see I've got water, wastewater, oil, natural gas, electric power, and communications are blank. So there's no communications support here. There's no damage functions for communications specifically. So if you do want to model communication facilities, what you can do again is bring them in as a user-defined facility and model them that way. We also have demographics within the software. So you have population, households, you have different age categories, you have different ethnicities, you have different income levels, you have population moving around from day to night, you have renters. Okay, so one reason they have all this information is so that you can identify more vulnerable populations when you start doing the analysis. So you can take a look at not only the structures that are being impacted, but the people who are being impacted as well. And if some of those folks are renters, and maybe they have renters insurance, and that renters insurance doesn't cover their flood damage, that might be some outreach that you could do as well. Is identify those renters who are in the floodplain, and just letting them know that you're in a floodplain and your insurance may not cover you. So we also have agricultural products in the flood model, and I'm in an urban area, so there's not going to be urban fields in Lynchburg. But what I could do is actually go to a sub-county level. There's different agricultural regions in a county, and I can look at the crop types. What they do is they take like the top 10 crop types in a region, in an agricultural region, and it'll populate your average yield per acre, and then the cost of that. So when you do the modeling, it will give you the crop losses based on how long the water sits around in the fields. And we also have vehicle information as well. So the vehicle count and dollar exposure of the vehicles. Hazus also provides losses to vehicles too. Okay, so that's the inventory for the flood model. You'll see this is all. I haven't updated any of it. This is all Hazus provided inventory. So it's a pretty nice data set. The demographics are a bit dated now. It is 2020 right now, and there's still 2010 data in here. So as we get the new demographic data, hopefully that will be updated in Hazus when it's available. So that's it for inventory. The next thing I want to show is basically how to set up a flood. So going from left to right, I talked about inventory. I'm going to hazard now. So the first thing I need to do in the flood model is define what kind of flood my community could experience. So I'm going to click on flood hazard type, and it asks me, is it riverine only, is it coastal, is it riverine and coastal? We'll talk about coastal surge later on in a different video. In Lynchburg we're inland, so I'm just going to select riverine only. I'm going to click OK. This helps the software understand what sort of data it needs to do the modeling. So I've just told it that I've got riverine flooding here, so it needs to have data for the entire watershed. If I had selected coastal, I would only need data for the coastal area in the county and a little bit outside the county. So it's basically telling the software what the limits of the study are going to be. So if I go to hazard and then user data, okay, you'll see that I've got 4 tabs here: DEM, FIT, depth grid, and HEC-RAS. For a level 1 analysis, which is what I'm going to do right now, I'm just going to use a DEM and have Hazus create my floodplain. Now, I'm going to warn you right now, I would never actually do this in this area. FEMA has already studied this city. They have a floodplain developed. They have a DFIRM, a digital flood insurance rate map, that I can download and I can look at. So I have a floodplain I can download from FEMA, and I'm going to do that next. But right now I just wanted to show you how Hazus does the flood modeling. And really, there are some parts of this country that do not have a floodplain, and this was supposed to kind of help those areas, and they're more rural areas. There's not a lot of population. FEMA focuses their studies on populated areas to cover the country. But there are some counties out west that just don't have a floodplain mapped, and this tool can help them a little bit in their planning to generate just kind of a basic floodplain for the community. So what I'm going to do here is I'm going to select DEM, and I'm going to select determine required DEM extent. So this is going to tell me how much DEM I need to download. So it'll just take a few minutes. Okay, and I'm going to click OK here. You'll see that right now this is not working. So what happens is it goes out to a site with the national elevation data sets, and it starts to download those for me automatically. But because the site's down, it's not going to do that request. So it will, however, tell me my northernmost latitude, my southernmost latitude, eastern and westernmost latitudes. If I'm doing a level 1 analysis, I'm not going to select 1 arcsecond. Okay, so it's like a 30-meter DEM. It's very, very rough, very large in size. So I want something that's a little bit better resolution. Okay, so I do 1/3 when I do the download. So what I've got to actually do is I've got to go to the NED site, and I've got to download that elevation model. Okay, so what I'm going to do is just pause here for a minute and come back. Okay, what I've done is I've opened up a website, viewer.nationalmap.gov. At this site, you'll be able to download the elevation data set that you need. So you see here on the left, I have data, and what I'm going to do is select the elevation product. So I'll click on that, and you'll see 1/3 arcsecond is selected for me. So that's what I want right now. If I do a coastal analysis, what I'll typically do is try the 1/9 arcsecond first. The coastal analysis is much smaller. It doesn't require the watershed. So the next thing I need to do is define where the location is. So up here, I have a button here that says enter coordinates. I'm going to click on that. So you'll see I've got my X max, X min, Y max, Y min. So what I'm going to do is go back to that menu I was looking at, and you'll see I've got my Y max here. I'm just going to copy that, and I'm going to go back into my web browser and paste that. Okay, I'm going to do it for the other 3 as well. So I've got my Y min here, copy that, X max. Make sure that you see that these are negative values. Okay, then I'm going to hit add to map, and you'll see the little section comes up here on the map, and then we'll click on search products. Okay, it's going to process for a few seconds, and it's going to give me these products. There's actually only 2 products here. There's 2 elevation data sets. They're giving it to me in both a GeoTIFF and an IMG format. Hazus can handle either one of these formats. So this one is smaller, so I'm going to go ahead and download these IMG files. So what I want to do is just click on download zip, and then I'm going to click on download zip again. Okay, and that'll start my download process. So I've actually already downloaded these 2 zip files. So I have those in my Hazus folder, my Hazus data folder. So under hazard input, I have a folder called DEM, and I've got these 2 data sets already downloaded. Okay, so that's where I put them. So after you download them, you make sure you extract it into folders. Okay, so my IMG files are here. So I'm going to go back into Hazus, and I'm going to close this menu, and I'm going to browse to those 2 files. Okay, so I'm going to go down to Hazus data, hazard input, DEM, and I'm going to select the first one and click select. I'm going to hit browse, click on the second one and hit select, and then we click OK. And it's going to warn me this is going to take a little bit of time. Canceling is not allowed. Continue. I'm going to click on yes. Okay, so at this point it's going to start processing, and it's going to bring in those elevation models, and it's going to mosaic them together, and it's going to clip them based on the watershed. So once this process is done, I'll have an elevation model that covers the watershed, so it's going to be bigger than my study region, and it's going to be a little bit outside the watershed as well, so keep that in mind. So what Hazus does is it takes the watershed boundaries and it buffers it out. So you'll need those additional areas as well. Okay, so that took a little over 3 minutes to do. I'm just going to click on OK, and I'm going to zoom out a little bit here so you can kind of see what this looks like. I'm going to move that region DEM down. And you'll see, let's see, my study region. So you can kind of see what that watershed looks like now. Okay, so you'll see under hazard, after I finish inputting the user data, I have this option develop stream network becomes available. So I'm going to go ahead and click on that, and it's going to ask me a question here. It's going to ask me to define the input stream drainage area. So this is how much area drains into one point to be considered a river or a stream. 10 square miles draining into one point is going to become what that's defined as a stream. So the smaller the number here, the more streams I'm going to have. The larger the number, the fewer streams I'm going to have. So 10 is pretty big. I'm going to select 2 and click OK. And it's going to ask me again, it's going to say processing is involved. This is going to take a little time. I'm going to click on yes. And it's going to start building my stream network based on my elevation model. Okay, so it's going to look at all the values in the elevation model, and it's going to fill in any pits that are there. Again, we're only modeling the riverine section, not any sort of lakes or that sort of thing, ponds. It's also going to do a pour-point model where basically if you drop water into a section of the earth, which direction is that water going to flow? Okay, so it's going to do that processing as well. And then it's going to start looking at how the water accumulates across the elevation model. The grids that have a couple of these grids that flow into them will be assigned a value, and then that grid will flow into another grid, and that grid will be assigned a larger value. And basically those grids that have a value of 2 square kilometers or 2 square miles rather, flowing into one point, those will be identified as a stream. So you'll see the streams are pretty jagged, pretty ragged, because they're being derived from a grid. So what we'll end up with is a blue stream that covers the study region, and actually goes outside a little bit of the study region as well. So this will take a few minutes to do right now. Okay, so this took a little over 21 minutes to complete. You'll see I'll just click on OK here, and we've got these little blue lines now that are representing our streams. So at this point, what I usually do is compare the stream network generated to what I want to make sure is covered in my modeling. So if I know where the streams are in the community, I could overlay those to make sure that Hazus has created those. If it has not, what I basically do is I go back to Hazard, develop stream network, and I plug in a smaller value than 2 to get those streams that I haven't been able to get to model. But this looks okay to me. Like I said, I wouldn't use Hazus to model the river network here anyway. What I would do is use FEMA's floodplain, which I'll show you how to download later. Okay, so the next step, if I go to Hazard and I go to Scenario, what I'm going to do is create a new scenario, and I'm going to run a 100-year flood, so I'll do 100 year, and click OK. Alright, and I'm going to select, I'm going to hit Add to Selection, this plus button here, and I'm going to left click, hold the left click button down, and drag it, and you'll see my line appears here. I'm going to continue to left click and drag for the river sections that I want to model. Okay, so I'm going to leave out a couple of ones. Let's see, I'll get this one as well. I'll get these 2. Okay, so after I've selected all my reaches, I'm going to go to Save Selection and press that button. And then I'm going to click on OK. Okay, so now you see everything in red is basically part of that scenario that I've created. So I'm going to go to Riverine and Hydrology. I'm going to click on that. Again, it's going to warn me. It's going to take a while to process. I'm going to click on Yes. So now it's going to run my hydrology for me. So in Hazus, basically Hazus uses the USGS regression equations to figure out what the flow is. So we're looking at peak flow in our streams, and we also have some gauge data in the software. So we have gauge data, and we have data that's associated with our large rivers. So I have the James River here. That's one of our large rivers. So there'll be some additional data for that river. So Hazus uses kind of its own methodology to develop basically what is our 100-year flow. It actually creates all the probabilistic flows for all of our reaches. And so that is kind of the output of this section is a table with each reach identified and each probabilistic flow for that reach identified, both at the upper and lowermost limits of that reach. Okay, so I'm just going to pause here while this finishes the analysis. Okay, the analysis is completed. It took about 11.5 minutes. I'll go ahead and click OK here. So you'll see nothing gets added to the map. Like I said, a table gets created with the different flow values in it. If we want to, we could take a look at that. If I go to add data here and I browse, all my data is in my regions folder, and this is Lynchburg flood. Okay, so you see I've got several different folders here. The 100-year scenario has been created. In it I have Riverine and case outputs that I can look at here. If I go up within the study region folder, I also have a folder called Riverine. If I double click on that, you'll see all those different grid files that get created when the stream reaches are being generated. Those are located here. You can take a look at those. There's also a geodatabase called FLANRIV output. If I double click on that one, you'll see I've got a QFreq table here. If I click on that and click on add, it'll be added to my table of contents, and I can right click on that and open it, and here's all my flow values. Okay, so cubic feet per second. This is a 2-year, 5-year, 10-year, 25, 50, 100, 200, and 500-year events. Okay, so just showing you where that is in case you want to take a look at it. And that's basically the output from this step. So the next step is I go to hazard and Riverine and delineate floodplain, and I'm going to map the 100-year. So I'm going to, everything says 100 already. I'm going to click on OK. It's going to give me a warning, and I'm going to click on yes, and it's going to process again. So at this point it's going to take those flow values, it's going to use the elevation model, it's going to create its own cross sections, and it's going to generate a water level across my reaches. And once that water level has been created, it's going to turn it into a raster and take that raster and subtract it from the elevation model, and that difference is going to be the flood depth grid. So this will take a few, again, some time to generate, so I'm just going to pause at this point. Okay, the hydraulics analysis is completed. It took a little over an hour to complete for this area. This process certainly can take a while, depending on the size of your study region. This could take several hours to complete. I'm going to click OK, and now you can start to see my floodplain here. I'll zoom in on it. So we have a orange hatch here for our floodplain, and then we also have a flood depth grid as well. So you can see that flood depth grid is there. Okay. All right, so the last step, and actually you can see if I zoom in here, there is one that is purple, so it's a failed reach here. So this one did not work out. So there's a couple things you can do to get this to work. So the first thing you can do is actually go in. If I go in and look at my C drive and program files and go to Hazus MH, there'll be a file called settings XML. So if I double click on that, okay, my settings opens up here. Okay, so there's a lot of good information here. What I want to do though is change debug hydraulics from false and change that to true. So actually let me open this up with Notepad or WordPad. Scroll down to debug hydraulics, and we could change that to true. And we can close this up, and we can go through the process of rerunning the analysis. If that doesn't work, what we can do is actually use a different digital elevation model. So if we have a different one, I know this area actually has LiDAR, so we may be able to do a different analysis with that. And the last thing we could do is basically go in and take a look at the key-freak table to make sure that we have values for this reach. So we can identify the reach. So the FL ID is 74. So if we open up this key-freak table and go to FL ID 74, okay, here we go. So we do have data there. So what we could do is look at the 100-year value, 1721. Okay, so we look at the key-freak table, and we can see I've got a 100-year value of 1721. So what I could actually do is go to hazard analysis, delineate floodplain, and I could find that 74 here, and I could actually run it as a single discharge and plug in that value for the discharge. I could just run it separately, so I could actually export all this out and just create a new scenario with just a single reach and run the analysis as a single discharge with that value in there, and that may give me a result as well. So a couple of things you could do. I'm not going to worry about it for this processing, but this does happen, and in some cases it can happen to quite a few of your reaches. So next step is to go to analysis and run, and I'm going to click on select all. I'm going to unselect what if. Okay, I don't have any sort of levee or flow regulation that I'm trying to model here, and I'm going to switch off of agricultural products since we don't have any of those, and I'm going to click on OK. And it's going to take that floodplain and apply it to my inventory. It's going to use some depth damage functions, and it's going to generate damages and losses. Okay, so this will take a few minutes, so I'm just going to pause it. Okay, the process is completed after about 4 minutes. I'm going to click OK. So at this point, I go to results and then view current scenario results by. Click on that, and you'll see I've got 100-year results here. I click OK. And now I can come in here and look at my losses. So general building stock, I can look at my economic loss for replacements, and I can map this. I can look at it by occupancy, so residential, commercial. I can look at it by specific occupancy, so this is the codes we talked about at the beginning of this video. And general building type as well, so wood, steel, concrete, masonry, manufactured housing, and then total loss as well. So we do have a breakdown of pre and post firm structures, so based on when the community entered into the firm. The structures before that time are pre-firm, the structures after that time are post-firm. So I'm going to look at total. Okay, so I'll click on total loss and map and close, and you'll see the losses there. by census block. Other results, if I have any essential facilities that are in the floodplain, those would be located here with damages. You'll see that we don't have any, so it's a good thing. Under results, we can also go down to transportation systems. So I mentioned Hazus does support bridge damage, so if we did have bridges that had damage, it would show up here. And then we also have utility systems as well. So if we have a utility that's in the floodplain, so you can see that we've got that here. So we have a damage percentage, and we have a dollar loss here. So we could actually map this to see where this is, and it's actually right here. It's hard to see, it's in black. We also get vehicle loss. So if we want to look at the loss of vehicles, we can click on that column and select map. We also have light truck and heavy truck as well, or we can do total vehicle loss. Okay, and that's by census block. Then we also have debris estimates. So if we want to look at our debris, we can click on a column and map it as well. And this will be shown by census block as well. And then we also have shelter estimates. So this is the number of people who are displaced, and then of those, who is going to seek shelter. That is here as well. Okay, then we also have summary reports. So if we want to look at a, let's say the losses, building losses, we could view that. Okay, and you'll see I have my units here. So these are in thousands of dollars. So this is not $96,000, $96 million worth of loss. And we have a little pie chart here that shows how that's broken down. So you'll see when I run the analysis at the census block level, I get additional information on business interruption loss. Okay, so that's provided here for me. Okay, some more pie charts. So this is our direct loss by capital stock category, so structural damage, content, and inventory. And then we also have our different business interruption losses shown here as well. And we also have, under other, we have a flood global risk report, which I can view. This takes a lot of the results and rolls it up to a report format. So we'll take a few seconds to generate here, but it's a pretty nice tool to have. It takes a lot of those results, and you'll see, but I can actually export this to a PDF or to Word, where I can edit it. So a couple of nice features there. It's going to be a multi-page document with a table of contents. Some of these have maps in them as well, so that's why it takes a little bit longer to generate. But again, just one of our tools to select from here. Okay, so this is what the global risk report looks like. You see it has a cover page and table of contents here, and gives you a little description of the region, people, the buildings. This is the inventory information, so this is not losses, this is telling you what was there before losses. This is exposure. We have some maps, like I mentioned, of the study region, and then also some of the total economic loss mapped. The damages, where those are expected. You can see a lot of residential damage. Expected damage to essential facilities here as well. You can see that nothing's been damaged. Debris generation, social impact, and economic loss. And this breaks it down. Residential, commercial, industrial, other loss. Okay, so that gives you a little idea of what this report can do for you. At the top left here, you can actually export to PDF or to RTF document that you can edit in Word. Alright, so this time I'm going to remove some of these layers so we can look at our floodplain. Okay, so I can see my floodplain here. So one thing I want to point out, what I'm going to do is actually, I've downloaded the Map Service Center's floodplain. So it's FEMA's digital flood insurance rate map that they have provided in the National Flood Hazard Layer. So what I'm going to do is open that up so we can kind of compare it to what Hazus generated. So I've already downloaded it, and I'll show you where to download it here in just a minute. But the layer I'm looking for is the special flood hazard layer areas. I'm going to add that. Okay, so I'm going to open up this attribute table to show you kind of these fields. So you'll see you have a field called flood zone. So we're interested in the AE and A zones here. Okay, those are our 100-year floodplain. You'll see that I also have a 500-year in this column here. It's designated 0.2% annual chance flood. Okay, so what I want to do is I'm going to do a selection by attributes, and I'm going to select from my flood zone equals to A, or flood zone equals to AE. Now click OK. Okay, so you can kind of see over my floodplain here. I could export that out. So I think what I'll do is just change the colors. So we'll look at the symbology of the floodplain. Do categories, flood zone, add all values. And we'll change this to blue. And we'll change X to no color. And I'll click OK. Okay, so the blue is the FEMA floodplain, the digital flood insurance rate map, and the orange is the Hazus generated floodplain. So we can kind of zoom in here. Let me put the Hazus generated one on top, and I'll make it a little bit different color here so we can see it better. Okay, so you can see it doesn't match up perfectly. It actually does a better job than I thought it was going to do. But you can still see that there's some area that Hazus considers a floodplain that is actually outside the official floodplain. So there are some issues here. I mean, in this case, you have a pretty large area. And you have some areas that the official floodplain covers that Hazus does not in a couple of these areas. So, there are some discrepancies here. And this is why I recommend using the official floodplain and importing that into Hazus. So I actually have a separate video where I go through converting the Map Service Center floodplain, which is a two-dimensional floodplain that we're just looking at right now, into a flood depth grid. Okay, this is what Hazus requires. It needs to know the depth of the water here. Okay, so I'm going to go through right now how you would bring in a FEMA floodplain. And that's it for level 1. So like I mentioned, level 1, you're having Hazus generate your floodplain. You're not changing your inventory at all. We went through the entire process. We got results. You can kind of see how long that takes. So let's go ahead and create a new study region and start bringing in the FEMA floodplain. Okay, I'm going to go ahead and create a new study region. I'll select create and click on OK. I'm going to call this one Lynchburg FEMA flood. Oops, and click next. Actually, for description, I'll put in using FEMA National Flood Hazard Layer, and I'll click on next and click flood, next, county, next, Virginia, next, and Lynchburg. And finish. Again, it'll take a few minutes to create the region, but in this region, basically what I'm going to do is import a depth grid, one that I've already created using the FEMA Map Service Center. So if you're not familiar with it, if I go to msc.fema.gov, okay, if I go there, I can basically search on the floodplain for my community. So if I click on search all products, and I select my state, and I select the county, in this case a city, Lynchburg City, and I'm going to click the city of Lynchburg, and then I'm going to click on search. And it's basically going to give me all the products that are relevant to the city of Lynchburg. So I have effective products, I have historic products. If there's a restudy going on, I may have some preliminary products here as well. There could be some flood risk products here too. So it's good to kind of explore what's available for my area. I want to go to the effective products, and I'm going to select the National Flood Hazard Layer, Data, County, and I'm just going to click download here, and I'll start to download this 15 megs. Okay, so that's where I find my official floodplain on the FEMA site. So let's go back to our study region. So what I've done is I've taken that floodplain and I've converted it into a depth grid. So I've got a separate video that shows you how to do that. I'm going to click OK here, and I'm going to click Open Region, OK, and Next. And I'm going to select Next again, and then Finish. Okay, so I'm just going to open my study region. So this time, instead of having Hazus generate my floodplain, I'm going to bring it in myself. I have a separate video on converting the Map Service Center floodplain into a flood depth grid. So if you're wondering how I got to my depth grid, please watch that video. So what I'm going to do is go to Hazard and Flood Hazard Type, and I'm going to select Riverine only, and I'm going to come down to User Data, and I'm going to select the Depth Grid tab and click on Browse. I'm going to browse to my depth grid. I have a 100-year floodplain depth grid. Now I need to set the parameters. I'm going to click on that button, and this is the 100-year, so I need to put 100 there. My units of measure are feet. I click OK, and I click OK. So it'll take a few seconds to process. Now what I can do is go to Hazard, Scenario, and click on New. I'll call this 100 year. Click OK. And you'll see that the user-defined depth grids are selected for me automatically. I can hit add to selection. Click the plus button, select any of this outline floodplain, and click Save Selection, and then click OK. Alright, the next step, I would go to Hazard, and I go to Riverine, and I go to Delineate Floodplain. Okay, so now it's going to use my depth grid, and I click OK, and I click Yes. And I wait for it to process. So it shouldn't take too long. You're just basically bringing in your own depth grid. Hazus is not completing the depth grid for you. So you see it took just 8 seconds. Now you'll see the depth grid is there. It's integrated into Hazus. At this point I can go to Analysis and Run. I can select everything that I want to analyze. And I can click OK. Okay, so this is similar to the previous example I showed, except now you're bringing in your own flood depth grid, which should be more accurate than what Hazus was approximating. So this will take a few minutes to process, and I'll basically have the results, the same category results that I had for the Hazus Level 1 analysis. And this could take a little bit of time to process as well. Okay, so it took about 3.5 minutes to complete. You'll see if I go to results and view current scenario results by, click OK. Basically I have the same results that I did with the previous analysis. So all of that is here. So that's basically it for running a Riverine flood, bringing in your own flood depth grid or having Hazus generated it for you. My next video I'm going to talk about setting up a coastal flood hazard. But that's basically it for this video.